Welcome to Physics Solution Center. In today's video, I want to show you how to answer tricky and technical uncertainty question. If you are revising for your exams, watch this video to the end as I show you some of the common mistakes students make while answering this question. Once you get it right, any question you see, you will definitely get it. Question number one. A unit may be stated with a prefix that represents a power of 10 multiple or submultiple. Complete table 1.1 to show the name and symbol of each prefix and the corresponding power of 10 multiple or submultiple. Kilo, 10 raised to the power of 3. Tera, this is 10 raised to the power of 12. That is pico, small letter P. All right, let's get to the next question. In the following list, underline all the units that are SI base units. SI base units are units that are fundamental. Other units are formed using them. So we have ampere, we have meter, other ones are seconds, kilogram, and the rest of them. The next question, the potential difference V between the two ends of a uniform metal wire is given by V equal to 4 Li divided by pi d squared. For a particular wire, the percentage uncertainties in the values of some of the above quantities are listed in table 1.2. The quantities listed in table 1.2 are values that are used to calculate density as 4.1 times 10 to the minus 7 ohm meter. For this value of density, calculate the percentage uncertainty. Now, when calculating percentage uncertainty, first you will look at the equation given to you. So make the density the subject of the formula. That will give us V pi d squared over 4Li equal to the density. When we are looking at the density, by the time we want the uncertainty in density, for the percentage uncertainty, you will do uncertainty of V over V, the percentage of that uncertainty, plus 2 percentage of D over D, that is the uncertainty of that, plus uncertainty in L over L, percentage uncertainty of that, plus delta I over I, uncertainty of that. So remember, you can see that pi and 4, I have not brought in anything because they are constants. Constants don't contribute to uncertainty. Equal to percentage uncertainty for potential difference is 3.5% plus diameter 2 times 3% plus length 2.5% plus current 2%. Let's add everything together. This will give us 14%. You can write it here, 14%. Let's get to the next one, absolute uncertainty. Absolute uncertainty, we have a formula for percentage uncertainty that leads to absolute uncertainty. Percentage uncertainty is simply absolute uncertainty over that of the density times 100 over 1. So if we have this as 14, the absolute uncertainty will be absolute uncertainty equal to the percentage uncertainty times the value. So that will give us 14 over 100 times 4.1 times 10 raised to 12 minus 7. Let's pick up our calculator and get the answer. You have 5.7 times 10 raised to 12 minus 8. Next question. Define density. Density of a material is mass per unit volume. The next question. A smooth pebble made from uniform rock has the shape of an elongated sphere as shown. The length of the pebble is L. The cross-section of the pebble in the plane perpendicular to L is circular with a maximum radius R. A student investigating the density of the rock makes measurements to determine the values of L, R, and the mass M of the pebble as follows. State the name of the measuring instrument suitable for measuring these measurements of L. In your learning, meter rule is measured to 1 millimeter. Vernier caliper is measured to 0.1 millimeter. That is the least it can measure. While micrometer screw gauge can measure to 0.01 millimeter. Now, let's use that to check. If L is 0.1242 meter, let's change it to millimeter, multiply it by 1000 to change to millimeter. So what can measure to one decimal place of the instrument is vernier caliper. So here would be vernier caliper. That is the secret of how to get the most suitable instrument to measure. The next question, determine the percentage uncertainty in the measurement of R. Percentage uncertainty is uncertainty in R over R times 100 over 1. That gives us 0.0004 over 0.0420 and times 100 over 1. The answer is 0.95, which is equivalent to 1%. Next question. The density of the rock from which the pebble in B is composed is given by rho equal to mr raised to n over kl, where n is an integer and k is a constant with no units. That is equal to 2.094. Use SI base unit to show that n is equal to minus 2. Now, this question is very, very important. This is SI base units, quantity sign units for it to answer the question. Now, let's write down the form of the expression given to us. Now, K has no units, so that one is out. Unit for density is kilogram per meter cube. Unit for mass is kilogram. And unit for length is meter, while unit for radius is meter. Let's put them together. We have kilogram per meter cube equal to kilogram r. This one is meter m raised to power n divided by m. This will come to this other side. Let's isolate m raised to power n. So we have m raised to power n equal to kilogram per meter times n divided by kilogram. See that this will cancel this. Remember this now. We have m raised to power n equal to m raised to power minus 2. Since the bases are the same, we can take the power at n equal to minus 2. Remember, since the bases are the same, we can cancel it out. take the power n equal to minus 2. Calculate the percentage uncertainty in density. Percentage uncertainty in density. So for us to do that, we will write the formula absolute uncertainty intensity over density 100 over 1. That is the percentage uncertainty. Let's go to the equation given to us. So we have here percentage uncertainty over density equal to uncertainty in n over n plus uncertainty in L over L plus 2 uncertainty in R over R. Now look at what I did there. The power that we had was minus 2. But when we were looking at uh, uncertainty here, I didn't write minus. Why? The reason is that for that constant minus 2, it's like you having 0.005. If you have 0.005, you can also write as 5 times 10 raised to the power of minus 3. That does not make raised to the power of minus 3 to be a negative. So it will not subtract the uncertainty. This is very, very important. So let's substitute the values. So when we have everything like this, we will put them together, say times 100 over 1. So this gives us equal to 2.08%. That is the percentage uncertainty. Determine density with its absolute uncertainty. We will use the equation to find the density. Rho equal to mRn over KL. We substitute the values to get the uncertainty. 9, 4. Let's put it in our calculator. The answer here 233.617. So uh, absolute uncertainty will be equal to percentage uncertainty times density. That gives us 2.08 over 100 times 2336.67, 48.6. You must change your uncertainty to one significant figure. So this will give you 50. Now, this significant figure will determine the decimal place for your answer. So we will write here as 2340, and here we write 50. This is very important. If you don't put them to align together, you will be marked down. So thank you. If you have any comments, make the comments, like, share, and send a question you want me to solve for you. See you in our next video.